The factor theorem is a theorem that connects a function value to its factors, which actually takes us back as well to the remainder theorem, which is, of course, the remainder when dividing by a factor. So the factor theorem says that a polynomial will have a factor of x minus k if and only if f of k is equal to 0. Okay, so this is a nice theorem that allows us to check whether or not something, a polynomial, has a given factor. We can just essentially do synthetic division to check whether or not that number k gives us a remainder of 0. And if it does, then we know that that factor, or that expression, is a factor of the polynomial. So let's see how this works in action. It's a pretty powerful theorem. We want to show that both x minus 2 and x plus 3 are factors of this polynomial. So what we're going to do is take the zeros of each of these. So we're going to start with the 0 of this one, which is a positive 2. If you plug 2 into this, you'd get 0. And we're going to do a synthetic division with that positive 2 out there and put the coefficients of this polynomial inside. 2, 7, negative 4, negative 27, and negative 18. We bring the 2 down. 2 times 2 is 4. 7 plus 4 is 11. 11 times 2 is 22. 22 plus negative 4 is 18. 2 times 18 is 36. Negative 27 plus 36 is 9. And 9 times 2 is 18. And negative 18 plus 18 is 0. Okay. So what I just found was that f of 2 is equal to 0 from the remainder theorem. Okay. I put a 2 in there and I got a 0 here. So f of 2 is equal to 0. And that tells me, since f of 2 is equal to 0, that tells me x minus 2 is a factor of my polynomial. So I've shown that x minus 2 is a factor of this. Now, to show that x plus 3 is a factor, I can actually work off of the leftover coefficients. Because what I've just discovered is that I can take this polynomial and write it as x minus 2 times, and then this right here, we'll write this out. We've got our x minus 2, and then times 2x cubed plus 11x squared plus 18x plus 9. So we've just found that this polynomial can be written like this. So if I want to show that x plus 3 is a factor of that, it means x plus 3 would have to be a factor of this leftover polynomial. So we can work off of just those coefficients and do another synthetic division using negative 3. Bring the 2 down. 2 times negative 3 is negative 6. 11 plus negative 6 is 5. 5 times negative 3 is negative 15. 18 plus negative 15 is 3. 3 times negative 3 is negative 9. And 9 plus negative 9 is 0. So I've got my 0 there. Notice I didn't have to keep going because I'm only using the coefficients of the leftover quotient. Okay. So I've just gotten that 0 there. That tells me that f of negative 3 is equal to 0. So I've shown that f of negative 3 is equal to 0. Therefore, x plus 3 is a factor of f of x. And now, what we've just shown is that my f of x, okay, I've now actually found my two factors, x minus 2 and x plus 3. And what's left has those coefficients. 2x squared plus 5x plus 3. Notice that the exponent on x has dropped by 1 from what we had here as well. Or you can think of it as I pulled out two different x's here, so I dropped the exponent from my original down by 2. So from 4 down to 2. So I've now written f in a factored form, but I'm not quite done because I'd like to be able to factor this if I can. And so now we're going to go ahead and factor 2x squared plus 5x plus 3. That's a quadratic with leading coefficient not equal to 1. So we'll take the 2 times the 3, and that gives us 6. We want two numbers that multiply to be 6 that add to be 5. And that's positive 2 and positive 3. So we take the 2x squared, and the 5x we break up as a 2x and a 3x, and then plus 3. And now we factor by grouping. The first group, we pull a 2x out. We're left with an x plus 1. The second group, we pull a 3 out. We're left with an x plus 1. Now that they both have an x plus 1, we can pull it out, and we're left with a 2x and a plus 3. So that's how our quadratic factors. So coming back to our f, we can write this in a completely factored form. We have our x minus 2 and our x plus 3, and then we have x plus 1, and we have 2x plus 3. And this is f written in a completely factored form. And so hopefully we can see now the how powerful it is to be able to show that something is a factor by just using synthetic division, and it breaks it down for us and it factors it for us. Okay, we don't have to worry about horrible techniques of factoring because this process gives it to us.